that new coding being done by agents and AI? Are you worried about your job? What's going to be the future for coding or engineers or in the complete SDLC? Who knows? Well, in this talk, I'm going to try to make some sense in the madness. So here we go. Now, let's first kick it off with one of the new tools to show you what the real power where we are at. Here's a tool called Cursor AI, and it's one of the new kind of coding tools. See here how I write my specifications, how I want my backend, my front end, my directory structure, my deployment code. And now I just say, hey, create me this application using these specs in the markdown described. It kicks off and it runs and it runs and it generates a multitude of files, right? Okay, the front end might take a little bit of time, and you see kind of the new file, the Docker file being created, and it just continues how it makes the difference. Now, we see it continue. It might take a while, right? It's still not fast, but still faster than humans typing all that stuff. We even got some end-to-end testing thanks to Playwright. Very simple things that I just wrote the markdown file of specifications. We review it file by file. We say, hey, this looks good, this looks good. And we kind of made it help us in a lot of the boilerplate to kind of work with our code, right? So this is a great example of how it's currently assisting us and even beyond kind of the typical tab completion. Now, of course, I want to try this, and this is the README that it generated. So let's try to open a terminal and see what happens. So sorry for my typing, it's not the best, but these are errors of mine. I'm just executing kind of the commands from the README. I activate the Python environment, and now I install the requirements. Let's see what happens. Okay, there's an error. It didn't create the requirements, even though I told it to. But I can ask it to fix this just by adding the terminal feedback that it was an error. And now it even creates the requirements, right? So you see this is kind of a feedback cycle, faster machine AI, and I'm kind of in the middle of controlling how the loop works. And now, obviously, the whole installation of the pip works. I'm very much in control. I still do the work, but the AI is really helping me to do this faster. And eventually, I have a simple application running. And we can continue this, but this shows you kind of from specifications to go to the next phase. So for me, and what others have been calling this is intent-based coding. And we've seen this a few times. We write the business specifications, and ultimately it generates the code. We've seen this a few times, 4GL, right? Okay. And we kind of want this to happen. And we give it a task, it has a specification, it does a plan, and it actually results in the code. And this is where a lot of people are heading into industry. So we're getting away from just the completion, just kind of the chatting with the code, just have it directly interact with our IDE. If you want to look into this, there's a language, speclang, from GitHub Next that kind of works on defining how that language of specification would look like. It's really cool stuff, and it is about us kind of better expressing what we want. And imagine kind of writing that code with the spec files over and over again, because there's a lot of knowledge in your head. You can even kind of bring some experts in the field, kind of say like, hey, I want to write these specifications, but assume the identity of a React programmer or a backend programmer, or maybe a mobile programmer. It doesn't really matter. So there's our kind of now ways of bringing that into kind of the execution of your IDE. So who am I? Why am I looking at this? Well, I've had like 15 years experience working with DevOps and automating systems. And this whole new thing of genAI is for me another level of automation. You can call this automation intelligence. I'm going to tell you right off the bat, it is not intelligence, but it's definitely helping us in a good way to kind of get our job done. So let's talk about the elephant in the room, right? So where will this end? Will we still be needed? And it's a question I keep hearing over and over again. And it's a valid question, but usually things are not that fast as the hype will go there. But what is real is that AI will generate more of the code. Whether they're going to be, the 100% code generators or the top ones, that's still to be seen how much the speed is. But it is already happening in reality. And here's just an example of agents or LLMs writing test code at Meta, right? 73% is already passing the review by humans. It's incredible speed, it's incredible improvements. And it's not only for code, it could be for writing your incident responses. This is an example at Google where you save a lot of time kind of typing and generating summaries for executives based for what happened kind of in the incidents. So what does the board think? They think, oh, well, we're going to get so much more productive and we're just going to kind of be able to lay off more people. And this is an example of a company just stating it publicly. Due to the use of AI, we're going to shift more employees and we're going to get more productivity. So hence, we need kind of less people. There's a little bit of a nuanced view here from the AWS CEO who says, like, well, developers should stop coding, right? If the machines can do the coding, why should the developer do the coding? But it is then the question on what is your skill then if you're not doing the code? So that's what we're going to find out today. So what turns out is that AI will take some tasks like writing and typing and kind of generating some of the stuff, but it will not take our jobs. It takes a lot more than what we're doing. Even the accountability is important, that there's still a human being accountable and not a machine, but it will only be a fraction of our time. So if you look at where a software developer spends time, it is only a fraction of time that is spent in the IDE generating the code. So some would say, well, the impact is only like minor of what it will do. And there's some truth to that. We can't over-rotate on just the time of a tiny fraction. A lot of the other time we're spent on waiting. And depending on your organization, this is probably something that you might experience. So you're waiting in between your coding. And that's another problem. Let's see if AI kind of in the future takes care of that. But we'll see. In reality, when people are evaluating kind of these code generation tools like Copilot and others, they're looking at kind of specific metrics that I want to measure. Sometimes they're thinking, okay, how many people can we kind of make redundant? Sometimes we want to compare, like if A and B are, A is using the tool and B is not using the tool, and they get more productive, well, that is kind of a justifier of using the tool. You can do like time saved and faster interactions with the tool in a way that it completes and writes the code faster for you. Maybe there's a KPI that you're measuring, on the whole of your company, your team, your kind of organization, and that is having an impact on those. Or maybe a key initiative moved from a monolith migration to more microservices. So those are kind of different ways for people measuring kind of their value of these kind of tools. It is tricky because there is no direct relationship that we can say like, okay, A is B and faster, but there is a trick that kind of holds us back. And you might even say that, we're going to have like new code metrics. It's not going to be lines of code. It's going to be the number of prompts that we put in. How fast can we generate an application? This is an example of kind of V0, one of the new kind of tools that helps you coding. And you see already like how many edits did I do, right? How many hops, how many prompts did I have to do to generate the code? So another way of looking at this is kind of, well, if it's only a fraction of the time, is this really true? And this is kind of an evaluation from the people at Adidas. They were looking at how much time their teams kind of spent on technical things. Well, you can kind of extrapolate being technical things, being coding and other kind of boilerplates. But the point is, they found out that the more mature the team, the more time they are able to spend on this. So that's an important factor. So even if it's a fraction of the time, it will depend on the maturity of the team. So it means that more mature teams kind of might have a bigger impact and even more velocity than not mature teams. Another thing that's kind of making sure that you have that impact is whether you have a culture of learning. And it's tricky because if you are in an organization that does not want to adopt, that does not want to change things in your kind of environment, well, then you might be scared to use those tools. So there's a gap, there's kind of a skill thread, and I encourage you to learn the new tools, because that's going to be important. And if you're afraid of that learning, I hope your culture of your environment or your organization is helping you overcome that fear. But it's really important that developers start learning these new tools. And typically you see something, and Ralph is one of the known voices, he will talk about this. Well, AI won't affect me. I don't care. Why? Oh, this is cool and it's useful. And you go into this roller coaster, eventually saying, well, I now have superpowers and I can create anything, right? And that's kind of the speed. Once you kind of experience that, you don't want to go back in there. And so the summary is AI will not take your job, but somebody who uses AI will take your job. And that's kind of the impact of these tools are happening. So it will kind of only take away some of the tasks, but the people using this will be faster in there. Now, the counter effect is the ironies of GenAI automation. And very early on in DevOps, there was an instrumental paper called The Ironies of Automation. And in DevOps, we've been automating for a long time, right? And we had the initial memes, or go away, or I will replace you with a bash script, kind of all those things. Eventually, we got more abstraction, and some of the things is the easy things of coding and spinning something up was easy. It became easier. But the hard things, like a SaaS running all those systems, that became a lot harder, right? So there's a kind of balancing act going on. And in these ironies of GenAI automation, they kind of go through what this means for the GenAI thing. And one of the things is we're kind of doing less producing of code and more evaluations. We'll have to be worried about any of the task interruptions. So we need to stay focused, and the AI cannot interrupt us all the time. It cannot present us with like overly complex things, so it needs to adapt to what we understand, and it kind of needs to make whatever it's doing understandable enough. And I'll give you a few examples on where I find this back in existing tools. So this is the sentiment: more reviewing, less typing. And you will see this everywhere, kind of a reviewing, and that's kind of interesting as the shift, right? So this is kind of not something that was invented. We're already experiencing this. The other thing is we're reviewing this thing, but if the AI is generating code that we don't understand, that's tricky. So we want to avoid that. This is write-only language, like only the AI can understand. And that's a real challenge of code being generated. And we've kind of trained it, unfortunately, a little bit on this, like obscure code and kind of things like that. And we need to kind of make sure that we still understand. So what this graph shows is that while the productivity of coding goes up, a lot of the current tools will also generate more complex code and more longer code. So we need to get better at this and reduce the cognitive load of these tools. And that's going to be a challenge for kind of more automation, but making sure that we kind of cope with all the changes. And we've already seen one of the examples in kind of the demo video, that they help us do a step-by-step breakdown of what was being generated, right? So it's not like we improve the whole commit. No, we're doing changes and deltas. And maybe they just help us to zoom in on a specific part of the code and not kind of give us these complex diffs that are hard to read. So this is a way of reducing cognitive load on the reviewing side. It is challenging, and we might kind of have the same experience as, okay, whatever, it looks good. And there's kind of an over-reliance on accepting what it generates. If it kind of becomes very good, we're like, okay, whatever. There's even a study saying, well, kind of people over the weekend using a Copilot, there are more eager to accept it because it doesn't matter that much, and kind of there. So this over-reliance is kind of one of the worries that we need to do. So hence again, more reviews and making sure that this happened. But there is a tricky part that we kind of are just over compliant in saying yes to the machines. Maybe another way of looking at it is like it is very important that this mental model of what is changed, how is it changing, and what is it affecting, that these things start being expressed to the user better. And we all know the code editor by kind of typing our code and maybe like an image or a preview or markdown. But what if it could adapt itself? This is the concept of a moldable development environment where kind of the developer editor adapts to what it's doing. This is fairly new and it's not very, kind of refined into the editors, but I think it's an important concept for us to understand what is going on. And that also helps in, hey, you do a change, this is the impact, or here's the natural language, here's kind of the code. What if we change the code? Can we change back the natural language? So that kind of synchronicity between code, visualization, and kind of specification, that is going to be ultra important to understand it at multiple kind of concepts while we are coding. And obviously, we want to give feedback as the end user of what's being generated. We can do the thumbs ups, thumbs downs. We want it to be fail-safe. It's not just going to go all the way to production. We have a versioning system in place. Well, you could use GitHub, Git commit, and something like that. But in this case, it's like a tool that generates visual designs, and from that code. So there's another way. And then why have it generate one solution if we can have multiple generated and the cost is fairly low? So we can see like alternatives and decide on those. It still requires the human to kind of make those decisions, but it's a lot faster than we used to do before. And obviously, we wanted to get direct feedback, as I mentioned. So you're typing something that's been generated. You want immediately to have it shown as the application. By the way, if you've just been rickrolled, this is the AI generating a code of a video player, which was an unfortunate kind of by result of what was happening. Anyway, direct feedback, that kind of cycle, we know that's kind of important. And we want to adapt to the mental model of the user, not the coder. And one of the tools that kind of helps in kind of coding and automating is GPT script. And it's not about the coding, it's not a language, but this is kind of something that is written in Markdown with some scripting. And well, you can kind of say, well, this is not real coding, and we had that debate for years. But it is important that you see that whatever tool is being used needs to adapt to the mental model of the user using it. And in this case, they like the Markdown, they like the CLI, they like kind of doing that kind of stuff. And this is how they operate. So this is just an example of it adapting to the user. So how does all this make sense? If I look back over all the years of DevOps, right? Initially, we had code generation, automation, infrastructure as code, YAML, all being generated. We soon found out that we needed to have tests to make it more fail-safe, right? So that's where the next thing is going to go. Like, how can we make sure if there's errors, there's issues, that we can kind of stop them in a better way? And then obviously, when it's in production, we need more monitoring, we need more observability. We need to understand what goes on under the hood. So maybe it's a step-by-step explanation that the tool is giving, and so on. And then kind of when we were monitoring, we feel, okay, why not architect the system to allow certain failures? And that's resilience engineering. And then we move further on observability, monitoring the unknowns. And then eventually we went to chaos engineering, where we were training because we were not doing the things anymore all the time. So we had to kind of shut down our systems to kind of make sure we were still ready for this. This helped us kind of refine our run books and our code and all the kind of the situations that dealing with failure. And I think that's where we're heading. Like there's a lot of productivity now on the 20% of code generation, but we will head towards kind of the learning and kind of the resilience there as well. Here's one of the ways of doing the learning. You turn your code base into lessons, right? Because one of the hard things of existing code is understanding what goes on. So kind of reducing that mental model of a person going into the code, that is really helpful and is going to save a lot of time. And eventually, when you talk about automation, there's levels of automations, right? One thing is it will help us, the chat, and we paste it in, and that's kind of doing simple steps. And then all the way up to, hey, we're going to do this autonomously, the computer, and they ignore the human. They're just doing. Well, of course, we're not there yet. But interestingly enough, we kind of had this similar kind of journey going into like CF Engine was a concept built on agents. And they kind of understood that it could do things on behalf of the user, and it had a set of rules. Chef brought in kind of more of the runs and kind of the acceptable, but it was doing this all the time. And then eventually we got into Ansible, which a lot of the people were just executing as, well, I'm going to run it now, I'm going to babysit it now, and then I'm going to execute this. So you see people have different layers of trust. And if, depending on your trust, one of the tools kind of speaks to you or doesn't speak at you. Speaking of those kind of like more advanced autonomous levels, one of the papers that came out was around how easy can computers fix GitHub issues, right? So they kind of made a test data set, and this is one of those synthetic benchmarks that people have been going at, and it's called like SweBench. And it's an interesting thing. It is synthetic, so it's not in the real world, but it shows you kind of how it goes. Here's an interesting video of the person or the team kind of building the first Sui agent that kind of did the first attempt to close this. And what they found out is that the agent was a lot better when they did it in steps. Here you can see like it moves almost like a human in the editor, scrolls through the window and goes out. So it's not about feeding all the code all of a sudden into one LLM call and we're done. So there's a lot kind of more things going on under the hood. And people have been competing kind of with all these different tools they have to kind of achieve, the maximum of fixing these issues. And it's really fascinating to see the different approaches to do this. But it's still synthetic, so I agree, we're not there yet, but fascinating nevertheless. So one of the tools that kind of came out of this is a tool called, it used to be called OpenDev, and now it's called OpenHands. And it helps kind of run these benchmarks in different ways. And it's something you can install, definitely something for yourself to see how it works. Another tool called ADAR not only kind of creates these kind of commits, as we've seen earlier, but they would auto commit if they find like the commit is actually, very safe. And this is kind of where do we draw the barrier, whether we are still doing the commit or the machines are doing the commit, right? Sometimes it gets it right, sometimes it gets it wrong. We're definitely not there yet. And then the one tool that kind of kicked the hornet's nest was a tool called Devin, and it was announced by saying, well, this is kind of a feedback loop as a commercial system, and was one of the first to bring this out. And you see it has like access to a workspace where the specs and specifications are. You see it having a browser, which allows it to serve a terminal to get the feedback. And you see kind of this is the whole loop back. One of the interesting things, and you can't try it because it's still kind of in a very kind of restricted mode of handing out like licenses, but they have a system that actually have multiple agents coding at the same time. So we saw kind of switching from one agent to another, but this kind of showed that it had like multiple agents doing the same work. And then now recently, Replit kind of took it a step further, and the agents are not just doing the code, but they get access to your database, they get access to some of your infrastructure. So instead of just only reading from the terminal or log files, they can read things that are in production. Anyway, just a continuation of getting more context to the tools to improve the results that it's coding. I think hopefully we're never ending up that we're putting the natural languages somewhere in our code to replace part of our code, but who knows, right? So it's another style of programming, definitely not recommended right now because of the reliability. And the tricky part will be, of course, like I said, it's going to deal with the failure. And, well, we can't just ask the agent to say, hey, what do you think? And we want to know what's going on. And ultimately, it's still going to be human who kind of will be in the loop, will be responsible to kind of oversee kind of what is happening in there. And this brings us to the concept of agents as digital workers, right? Like, if they can do the work of an employee, why can't they be employees? And this was a little bit of a clickbait by the first company contracting an agency instead of a human. Since then, they backed off because they got a lot of slack. But it shows you that people are thinking about these issues. And what about we all know team topologies, but what about agent team topologies? Will the agent be able to kind of control and manage users, or will it be always a sidekick? Can they kind of be their own company with a lot of agents? Fascinating kind of things, and a lot of analogies can be made with humans and agents kind of collaborating. They already noticed that agents will be also in different classes, much like people and engineers working. There's going to be specialists. There are going to be more generalists, and you will see that kind of the generic agents will become a commodity, and the specialist agents is where kind of people will pay more of the money for. Now, you see this as agents collaborating. This is a phrase called like cultural technologies, an LLM being cultural technology. And Wikipedia is a piece of technology, for example, that transmits a certain culture. And you will see that this is exactly what an LLM does. It spreads the culture. And we've seen it a little bit with the Rickroll, right? The funny kind of culture of the coding that is kind of part of the culture being spread, and it's going to be replicated in what we do. But unfortunately, that also brings it to being toxic behavior. One agent can overrule other agents. That's kind of a scary thing. So we need to have the resilience of having an agent that oversees, or is going to be us, or an agent helping us to oversee. And that kind of can lead to an AI code of conduct. OpenAI described a spec saying this is what agents should adhere to. It's not the laws of Asimov, but still it expresses what the agent should do, and that's kind of like similar to a code of conduct. A lot of this came from this experiment by having multiple agents talking to each other for a whole day, keeping track of agents going to a village, one agent talking to another agent, and this kind of simulation of human behavior. And that's kind of how people got a lot of the ideas to go further with this. You can play with it for yourself if you want to. This is kind of like a similar browser thing where you can kind of instruct and have you play your own stories. But what they found is that communication and diversity is key to get results. So this paper kind of takes that village into the world of software coding, and they found that the more diverse and the more communication is done, the better the results as such. Ultimately, all of us working together are more productive. We are wondering whether this has an impact on our team size. Will we have a team of one? We will kind of have one-day sprints. Will we finally kind of get through our backlog? We don't know, but it's kind of like currently we are experiencing, but something will have an impact on how we are working. Some would say kind of smaller teams with autopilots, and then kind of with a few machines. Again, it is all speculation at this time. What we kind of all feel is that there's something of the specialist, right, that does something really well. They might get like insanely paid, like the COBOL developer. But in general, there will be kind of more demand for the generalists, and not the generalist as the full stack developer, but the ones that kind of are able to learn faster as such. And this is kind of the real crux, like, continuous integration, continuous development, continuous deployment, continuous learning. That's probably where we are at. And not just in your domain, but you kind of need to adapt and be almost like the moldable person who kind of can go from A to B. And that learning is where we will have to spend all the money, right, that we save on the productivity, which is kind of the interesting part. We might even do more ops. We clean up after agents. Who knows, right? Maybe this is, all of a sudden the devs will turn into ops because they're doing this. Who knows? One of the other kind of tidbits is, companies are getting smaller to reach a Series A's. Is this kind of with more productivity, with more coding? Will the trend kind of continue? We don't know. And then we always kind of overestimate new technologies. That's the hype cycle, right? But usually we haven't kind of fully exploited the capabilities, and we're like, it's not that the technology is being reinvented all the time that we're doing, but the way we apply it is always reinvented right now. And that's kind of the capabilities. And of course, then there's the long spread of the ultimate adoption. You might ask kind of how long will it take to that we get there? Well, it's probably going to be a lot faster than having Linux on the desktop. But, we are going to be better on this. And I love to hear about your journey, what you think about this, and how will you improve using AI in your day-to-day job, and how do you think your job is changing. Thank you very much for listening, and I hope for a good conversation and a good discussion about this.